Hello everyone, welcome to today's class. Yesterday we stopped at integration, we covered everything on calculus. So today we'll be looking at something new. We'll be looking at statistics from the JAMB syllabus. We'll be looking at statistics. So I'll be telling you everything you need to know about statistics. So stay with me. Let's just give others like 2 minutes to join us so we can begin. All right. So today we'll talk about statistics. I'll be introducing you to statistics. I'll be covering everything you need to know on statistics. I believe our students have started joining the class. Should we give them like some more time to join again? Should we give them like 1 minute or should we begin? Alright, so first of all, what is statistics? What is statistics? What do we understand by statistics? So we can say statistics, take note, we can say statistics can be defined as the word collection and interpretation of data. Please write this down. Statistics can be defined as the collection or interaction of what? Data. So let me draw the world for instance. So all around the world, we use statistics to what? Analyze the difference. So you can say we use statistics to what? Analyze different variables all over the world. So this is the world, and we use statistics to analyze different variables. For instance, now we have, let's say we have humans here. We have humans and want to analyze their height. We will analyze it using what? Statistics. Now, if we want to analyze now the weight of a ball, or let's say we have a box or a cube. We have a cylinder. We have a cone. And want to analyze their weight. We'll also use what? Statistics. Also, let's say we have different choices of food. Let's say we have an apple, we have bananas, so we also use statistics to analyze food, different foods. Now, let's say colors. We have this color, we have another color, we have another color. Let's say this is red, this is blue, and this is yellow. So they are all colors. So we use statistics to analyze colors, to analyze height, to analyze food. All over the world, statistics is used for analysis of different variables. So the moment you collect data, the next thing is to what? Interpret that data. And that's what statistics is what? All about. Please take note of this. It's very, very, very important. Very, very important. So these are all variables. They are called variables because they change. Now the height of one person is different from the height of this person, it's different from the height of this person. So it's a variable. It what? Varies. So we call it, this is what? Variability. So statistics is all about studying the variability. Same thing as the cone. This is a cone, this is a cube, this is a cylinder, and this is a cone. This is what? Banana. This is what? Apple. So they are not the same. So you can analyze it. Since they are not the same, you can what? Analyze it using different statistical methods. If you can hear me properly and you can see me, please let me know. Because yesterday, I don't know, some persons had poor network and they were not able to hear me properly or see me properly. So I don't want today to be like that. Please just let me know in the comment section if you can hear me and you can see me. Alright, welcome. Who is this? He said hi from China. Akin Rede Messi. Hi, welcome to today's class. Alright, let's proceed. So next up, we're looking at two types of statistics. We'll be looking at what? Two types of statistics or different types of statistics. So let's clean this. Let's clean this. Let's clean. I'll leave this in case you're still drawing. So now we're done with what is statistics. We are moving on to what? Types of statistics. Types of what? Statistics. So statistics is made up of two types. One, we have what? Inferential. We call it inferential. Inferential statistics. And the next one is called what? Descriptive statistics. So I'll be telling you the difference between what? Inferential statistics and descriptive statistics. So let's say I can clean this now. You're done writing, right? So I can clean this. Okay, let me just clean up to this extent. Let's say now this world now has different persons. So for inferential statistics, it's all about taking what? Samples. So now we can take 3 persons out of there, out of the entire population, taking samples out of this population. We took 3 samples, then we analyze these samples. So that is what inferential statistics is. First thing you need to note, take the what? Samples. Then next you what? Analyze it to make judgments or claims about the what? Population. Analyze to what? Make a what? Judgment or a claim. So that is what inferential statistics mean. Why descriptive statistics means collecting data and what? Talking about that data you have collected. That's you're describing it. This course is a very interesting course because it helps you see the world and be able to analyze using different methods. Now, for this descriptive statistics, we normally use histograms and we use graphs. So this is a histogram, this is a graph. Let me spell it here. Histograph, a normal graph. To use it for what? Descriptive statistics after collecting data. So the first part now of statistics deals with what? Descriptive statistics, and the second part of statistics deals with what? Inferential what? Statistics. So please, I hope you're understanding and you're following up what we are saying. Alright, please write this down. Let's go. Now, in order to understand statistics, you need to understand one or two terminologies. Now, let's say population, example, population. 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 Now, what do you understand by the word population? So, we can say population refers to the what? Total amount of things. That's what we understand by what? Population. Now, under things, it can be people, cats, cars, people, cats, car, and etc. That is what these things refer to. The thing can be either you're analyzing people, you're analyzing cats, you're analyzing car, and so on and so forth. So another thing you need to understand is what? Sample. Another word So now we can call it, instead of us to use example, let's use terminologies. Because you'll be seeing these terminologies in statistics. So sample refers to the what? Part of population that is used for study. So this refers to the what? Parts of the what? Population that is used for study. So that's what we refer to as what? Sample. The part of the population that is used for study. While population is what? Amount of things. The things are either people, cat, car, and so on and so forth. Please write this down. Please write this down. Now, let me clean this part. Okay, one more thing. Let me clean this part. One more terminology you need to know is the sample size. So now, what do you understand by the sample size? So the sample size is the total amount of things in the sample, the total amount of what? Things in the what? Sample. That is what? The sample size. So I see the way they are connected. From population you get your sample, from sample you get your what? Sample size. Now let's say the sample sizes are made of variables. So now the variable is the characteristics of the thing we are about to measure. When we talk about the measurement of height of humans, the mass of shapes, the different type of foods and the rest, all those variables, they tell us this sample size. Now inside them we have the variables which we measure. So under variable we have what? Two types. We have what? Categorical variable and categorical variable. Take note, we have what? Categorical variable and we have quantitative what? Variable. Now, this variable you can also write it as what? Data. So we can say categorical data and quantitative data and what? Categorical what? Data. So this is what we have under the what? Variables. Now let's look at something else. Let's look at something else. Under this quantitative data, take the definition, take down. Quantitative data are data that is measured in numbers. For this quantitative data now, these are what? Data that are measured in numbers. Please take note of that. The data that are measured in numbers. Why categorical data, they are what? Data that what refers to the values that they refer to the values that what place things into different groups or categories. Or what? Categories. So for quantitative data, these are data that are measured in numbers. While for categorical data, these are data that refers to values that are placed into different groups or categories. Now, examples of this one that are measured in numbers are what, let's say the height. We can measure height. Let's also say we can measure the weight. So I can measure your height, I can measure your weight. I can also measure your midterm score. Your midterm score. Why for categorical data, which refers to the things that are measured in different groups, we have example, let's say your hair color, your type of cat, or your breed of dogs, type of cat, your letter grade. If you get A, that means excellent. If you get B, good work. Just like that. So letter grade, they are also under what? Different categories. Alright. So let's look at something else. Please, before I move forward, I want to let me know if you're following up this class, if you're understanding what I'm saying. Please let me know in the comment section. If you are following up the class, let me know in the comment section. Chisom Divine, are you following up? Akinrinde Mercy, are you following up? If you are following up, let me know in the comment section, please. Please let me know in the comment section. Please, please, please. Very important. Very, very what? Important. So let's wait for some response so we can proceed. Because this is an interactive class, we need to get feedback if our students are actually following up on what we are saying. Alright, they are following up, so I can continue. I can proceed. They say they are following up, so I can proceed. Okay, let's look at something else. So for categorical variables, we have two types of categorical variables. Now, for categorical variables, we have what we call categorical and ordinal. we have what we call categorical and ordinal, and we have what we call categorical and nominal. So under categorical variables or data, let's see categorical data. Okay, let's use variables. Anyone you want to use. Or data, put it in bracket, or data. We have two types. Now, for the first one, we have categorical and or what now. Take note, categorical and ordinal. And we have categorical and nominal. So there are two. Now, under this categorical and ordinal, this is the way we arrange things. Is the logical ordering to the values of a categorical variable. So we can say is what? Logical ordering to the what? To the values of a categorical variable. Example, when we say letter grade, we can arrange them in logical ordering. So you can say C. No, I don't like writing F. Let me change it to E. I don't pray for anybody to fail. So E, C, C plus, B plus, A, and what? A plus. So there's a difference between A and A plus. There's a difference between C and C plus. There's also a difference between B plus and what? B. So this is a way of ordering them logically. Why? For categorical and nominal, there is no what? No logical ordering to the variables. No what? Logical ordering. No logical ordering to the what? Variables. There is no logical ordering to the variables. So example, we have hair color. Example, we have hair color. For hair color, it can be red, it can be blonde, it can be brown, it can be blue. So it can be red, brown, blue, blonde. So it can be any color. Then for quantitative variables, please write this down first. Then let's move to quantitative variables. Do you understand this arrangement? This one is logical ordering for categorical ordinal. While for categorical nominal, there is no order, it's just normal. If you notice now, it's going from E, that's the worst grade, to C, to B, to the best grade, A. E, C plus, B plus, A, then A plus. You will not see E, B, E is A, no, it's arranged orderly. So that's why they call it what? Categorical, logical ordering. But this one, there's no way you can order it. You can put anyone first, you can put anyone at the last. You can put brown here, you can put red here, you can put blue here, you can put blonde here. So there's no way you can order it logically. You get? There's no logical ordering to the color. So that's why they call it nominal. It's normal. Nominal simply means is what? Normal. Ordinal means is following an order. So let's move towards quantitative variables, quantitative variables. Now, for quantitative variables, it also has two types. One, the first one is called what? Discrete. And the other one is what? Continuous. So we have discrete and we have continuous under quantitative variable. Now take note, for discrete, this refers to variables that can only be measured in certain numbers. So it refers to what? Variables So discrete refers to variables that can only be measured in certain numbers. Example, number of pets you own. Example, we have the what? Number of what? Pets you own. Now for number of pets you own, it can be 0, it can be 1, it can be 2, it can be 3, it can be 20, it can be 100, but it cannot be 1.2. You cannot own 1.2, so this is wrong. You cannot own 3.5, so you cannot own a pet in decimal form. This must be a whole number. Either you own 0 pets, or you own 1 pet, or you own 2 pets. So these are variables that are measured in what? Certain numbers. Take note of this. Certain what? Numbers. They are measured in certain numbers. Then for continuous quantitative variables, take note, this refers to variables that can take any numerical value. They can take on any numerical values. So this refers to what? Variables that can what? Take on any what? Numerical value. For example, let's say the weight. You're measuring the weight of an object. You can say the weight is what? 105 kilogram or pounds. You can say 185. You can say 201.50. It's allowed. You can add decimal because it's what? Weight. But for discrete, only certain numbers. But for continuous, you can take on any. You can take on any numerical value. So take note of these two. Please take note of the two of them. If you understood this explanation, please let me know so we can proceed. Let me know so we can proceed. Okay, I believe everybody is following. I believe everybody is on the same page with me. That's what I believe. Everyone is on the same page with me. Alright, let's proceed. Let us what? Proceed. Now, we'll be looking at something else. Now, let's look at mean, median, and mode. Mean, median, and what? Mode. So, if we draw humans, so let's say this is mean. I'll explain why. And we draw another set. So this is what? Median. And we draw a final set. Alright. So let's just say this mode, let's make them the same height. Let's make them the same height. Okay, so this is what? Mode. So now, we are explaining what? Mean, median, and mode. For mean, if you have a set of samples or data, to get our arithmetic mean, we will simply what? Sum up all these variables and divide it by the number of variables, the total number of variables. So now let's say our mean x is equals to what? x1 plus x2 plus x3 plus x4, 1 2 3 4 5 6 plus x5 plus x6 all over what? N, where our n is equals to what? 6. N is equals to 6. Here n is equals to what? 5. Here n is also equals to what? 5. This is the total number of what? Sample. So to get our arithmetic mean, we have to sum x1, x2, x3, x4, x5, x6. x1, x2, x3, x4, x5, and what? x6. And divide it by the total number to get our what? Arithmetic mean. You can also write it as this: 1 over n sigma from n I equals to 1 then x I. This is another way we write it. So this is for what? Mean. Next up, let's look at our mode. Our median, sorry. Before we look at our mode, let's look at our median. For our median, if you notice, we have 5 different samples. So the median is simply what? The one at the center. The data or the sample at the what? Center. That is what? Our median. Then for mode, if you watch closely, these 3 are identical. So they appear there 3 times. So the mode is the one that has the what? Most frequent appearance. The value that occurs most frequently. Now you can use this sample or you can call it what? Value. So the mode is the what? Value that what? Occurs most frequent what? That is our mode. Because this one is appearing 3 times, so our mode here now will be what? That value. That value that is appearing 3 times. While our median will be what? The what? Center value. That's this one. While the mode is this. They are the same value. So if you just get the value, you write it there. The one that appear more times as frequently. Alright. So if you understood this point, please let me know. Please let me know. Please let me know. If you understood this point, let me know. So there's what we call measure of dispersion. Measure of dispersion, which means the amount of space between values. The amount of what? Space between values. We also have what we call variance and standard deviation. We have what we call range, and we have what we call interquartile what? Range. These are all what? Different what? Terminologies we use in statistics. So please take note of that. Now, let's look at those things I just mentioned now. Standard deviation, range, and interquartile range. Let's look at them. Standard deviation, range, and interquartile range. Now, should I draw again? Okay, let me just draw it now. It's almost similar. So we have what we call here variance and standard deviation. We have what we call range, and we finally have what we call interquartile range. Now, for standard deviation, the standard deviation, we can use an equation for the standard deviation. Let's say we have something here like this. The range, let's just say we have this, we have this, we have this, we have this, we have this. Then the interquartile, let's say we have this, we have this, we have this, we have this, this, and what? This. Now I'll explain them for you in just a second. Now for standard deviation, we have this formula. This sign represents standard deviation, is a Greek sign called sigma, also used as stress. So this is the equation for standard deviation: 1/n, 2 summation of n I equals to 1 into xi minus the mean value all square. Then you take their square root. So now this, like I told you, this is our what? Standard deviation. That is our standard deviation. This is our what? Number of persons. Number of persons. Why? This xi is the size of each person. The size of each person, that's xi. Then this x bar is the what? Mean value of all persons. X bar is the what? Mean value of all persons. I just explained what mean is before now. That mean is simply adding all the values and dividing by the number of value. So we have our mean value, we have the size of each person given, we have the number of persons. I told you what n is before now. So I told you what n is, I told you what mean is. So you have those two. Now this is the only new thing I'm showing you here now, which is xi, and is the size of each person. Then this is our symbol for what? Standard deviation. When you have those values, you simply what? Substitute it into this equation and you get your value for what? Your standard deviation. Now the range is simply telling us what is the distance from the middle term to each of the term. The middle term to this place, the middle term to each of the term, the middle term to each one. What is the range from the middle term to each of the term? That's what our range is simply telling us. Very simple. While our interquartile range is telling us the value with the highest percent. Let's say this side is what? 25%. As this two, 25%. This other ending part is what? 25%. So this part now, this ones, let's say they have what? 50%. And the center one, the ones with the colored there. So interquartile range is telling us the total, the value with the highest percent, that's 50%, that's the interquartile range. While this one and this one, they are 25%, 25%. Together we make what? 100%. So this is what variance and standard deviation mean, range mean, and what interquartile range mean. Very simple, very what? Simple. Now, for the standard deviation, this is the first formula. But we have another formula for standard deviation. We have two what? Formulas. I've given you this one as the first one now. Or let's call it equation 1 when you want to calculate standard deviation. Now, for the next one, it will now be what? 1 over n minus 1. This is equation 2. Equation 2 is what? 1 over n minus 1. Every other thing will remain the same. Every other thing what? Remain the same. Now let me tell you when you use that first one and when you use the second one. Now, for the first one, if our survey does not cover the whole population, we will use that first one that we had as what? 1 over what? N. That is if and only if the survey does not cover the whole population. But if the survey that is conducted is a clinical survey, we will use what? N minus what? 1. Please take note of the both of them. Now, let me give you the difference between what? Standard deviation and what? And variance. Now, these two, we have variance and standard deviation. Let me just give you the difference between both of them. For variance, take note, for variance, the variance now is the squared variable. Now, it is square standard deviation. For variance, if you square, you put all these things into brackets and square it, that's for variance. While for standard deviation, standard deviation is what? The quadratic mean of the distance from the mean. So the quadratic mean of the distance from the mean is what? The standard deviation. That's why we are subtracting each of the person by the mean, so that we'll get the quadratic what? The quadratic mean. And that's why you see that this is raised to power 2. When it's raised to power 2, that means if you expand it, you have something like this: xi squared and once you see a polynomial like this, just know that it's a what? Quadratic equation. So the standard deviation helps us get the quadratic mean, while the variance is what? The squared of all the standard what? Deviation. So that's what we have. So we are calling it a day. Today we're closing very early. Yes, we don't have much things to do on this topic. You just need to familiarize yourself with all these things I've explained. Familiarize yourself with each and every one of these things I have explained, and that's all. So thank you for staying to the end of today's class. Hope to see you tomorrow, the same time and the same venue. We'll continue from where we stop. Thank you and God bless you. In case you're new to this channel, please don't forget to subscribe. It's a way of supporting our channel. Subscribe, smash the like button, and drop your observations or your questions in the comment section. This is my number over here, 081-263-88049. You can send me questions on WhatsApp and I'll help you solve them. If you're not in this country, you can use +234 81-263-88049 to reach out to me via WhatsApp. Thank you and see you in our next class.